Hey everyone, welcome back. Today we're going to be talking about breadth first search, the graph traversal algorithm. So yesterday I talked about depth first search, and if you haven't watched that video yet, I highly encourage you to watch it, just because personally I find depth first search a little more intuitive. So, if you remember with depth first search, we sort of started at really an arbitrary node, and the process kind of brought us down a branch of nodes to the end, and then we used the stack to, once we've reached the end, sort of backtrack back to where we were to keep exploring the graph. Now, the difference between breadth first search and depth first search is, unlike using a stack like we did in depth first search, we're using a queue, which is first in, first out, rather than the last in, first out of a stack. So, this one has 3 steps. It's add a node to the queue, visit every neighbor and mark it as visited, and then once all the neighbors of a node have been visited, we pop the first item from the queue, and we proceed with the next one in the queue. So I hope that makes sense. It'll make a little bit more sense once I actually get into the process of doing this. So, like I did yesterday, I'm going to start on A. So, let's add the node to the queue, A, mark it as visited, and we'll put that in our output. Okay, now, unlike depth first search, where we chose the neighbor with the lowest key value and went all the way down the branch, we're going to add every neighbor of A to our queue. So what are the neighbors of A? We have B, we'll mark that as visited, C, mark that as visited, and we have G, so we'll mark that as visited. So A, B, C, G. Okay. Okay, so now every neighbor of A has been visited, so we're going to pop that off the queue. So I'll just draw an X there. Next is B. B, every neighbor of B is also visited, so I can take that off the stack. C, every neighbor of C is visited, so I can take that off the stack. And now we're at G. Has every neighbor of G been visited? No. So what do we have? We have F first, so we'll put F here, mark it as visited, put it in our queue. Okay. And then we also have H as a neighbor of G. So H, H. Okay. Okay, so now we've reached every neighbor of G, so we're going to go ahead and pop that off the queue. We've reached every neighbor of F, so we're going to pop that off the queue. And now we're at H. Now, what are the unvisited neighbors of H? It's just E and D. So boom, E, okay, and then D also. Okay, so we've reached every neighbor of H, so we can go ahead and take that off the queue. We've reached every neighbor of E. We can go ahead and take that off the queue. And now we've also reached every neighbor of D. So we finally take that off the queue. Our queue is now empty, and our breadth first search is completed with the output A, B, C, G, F, H, E, D. So there you go. That's breadth first search. I hope that made sense. If you have any questions, or if you want me to make a video maybe on the actual code behind this algorithm, let me know in the comments, and I'll certainly do that. Thanks for watching.